progress. All right, so the proportion we're going to look at here is P for proportion. And it is the proportion of adult women in New York around 2010 suffering, classified as with, there we go, let's go with obesity, and I'm going to come back from my hypotheses in a minute. I have a sample where in my sample, P hat is the symbol for sample proportion, is, what was it, 17 point something? Spreadsheet says 17 point, let's call it 17.6. It's about 17.6%, which as a decimal would be 0.176. And that right there is proportion of hotel maids with obesity. They happen to be adult women in New York. It's not the same as, let's write down the proportion. I found a study in 2000 said that proportion was about 20.7, yeah, 20.7%. Okay, it's different. So I have two possible claims I could make based on this information. I could claim that the proportion of adult maids, proportion, let's stick with adult maids in New York with obesity is not the same as the population proportion 20.7, or I could say the proportion of maids classified as obese is lower than the population proportion of 20.7. Let's go with the lower than this time. That's going to be my claim. Portion of hotel maids with obesity is less than. Population proportion of 20.7%. All right, so again, based on my claim, what the population proportion represents in symbols, what are my hypotheses for the null and the alternative? How would you write that in symbols? So typical null hypothesis, the proportion is 20.7. Alternative hypothesis, proportion is less than 20.7. And I got to state a percent. So either you have to state the percent symbol or state it as a decimal. Typically, we'll state it as a decimal if you look at the book and the homework problems. But since I started writing it this way, I'm just going to leave it as a percent. And I'm going to go with the standard alpha significance level of 5%. Okay, so I have my claims, I have definitions of what the population parameter is, and I have information about my sample. So we're ready to run the stat key and do the test. Okay, so let's see, double check in stat key, BMI of 30 or higher is this group. And double check that is a count of 13 of them. When we go into stat key wants to know for your proportion, what's the numerator and what's the denominator. Okay, so I had to go back and find that. And then we got to go to the right stat key page. So I recommend everybody try this in stat key. Which stat key page do I want?
Test for proportion.
Yeah, hypothesis test for a proportion. So we're going to choose that sucker right there. Okay. So again, hypothesis test for proportion. Now this one's a little easier. We don't need all of the data. We just need the counts that I mentioned. So we're going to edit the data. And the count for this was 13 of the maids had a BMI of 30 or higher. Out of a sample of 74 maids, we have BMI measurements for. And so if I hit OK on that, I should get that 17.6% that I stated earlier. So that confirms what I had in my spreadsheet. Then I have to adjust what the null hypothesis says. So the null hypothesis, I found a figure that was 20.7 around that time frame. So in around 2010, a study said that around 20.7% of adult women in New York were classified as obese. And we're comparing that. You have to enter it as a decimal. So I should have written it down as a decimal in my notes. So that would be 0.207 as a decimal. All right, so I'm going to make some corrections to my notes here. That. All right, so we should state it as 0.207 because that's the way most software deals with it. 0.207. And just want to make a note, I'm using calculators to do these hypothesis tests. You cannot do a hypothesis test without some kind of statistical calculator. That calculator can either be something like StatKey. There's tons of professional software companies buy to do these kinds of things. Or I can use a spreadsheet to do it too. Spreadsheet has formulas that will do all this. I'll show you how to do that next week on a spreadsheet. But you can't do this by hand. Well, you could, but it would be incredibly painful. You just wouldn't want to do that. What other correction? Oh yeah, I should add here, in order to use StatKey, I need to know the numerator, 13, and the denominator that got me that proportion, 70. So again, to do this in StatKey, I need the null hypothesis value, and I need the sample proportion as a fraction. What kind of test am I going to run here? Two-tail, left tail, right tail? Yeah, because of the less than there, we're going to do a left tail. So note, left tail test. All right, let's do the test. So we got StatKey ready to go. We've got our data in there. 17.6% was our sample proportion. We've got the null hypothesis proportion, which I found in another study. And now we generate. And I got 7,000 this time, that's fine. Notice, that is a symmetric bell-shaped curve. Okay. Similar, but slightly different than the one we had for an average. And we're doing a left tail. Okay. Next thing I have to do with the left tail is plug in my sample value. My sample value is 0.176. And I get a p-value of 0.299. You probably should get something similar, but different. All right, so I'm going to sketch that and I'm going to reset it just to see that it's going to be a little bit different every time. All right. So putting all this together in a sketch. Sketch your best symmetric bell-shaped curve. And in the middle, we put a P for the population proportion. And that is the 0.207. The 20.7% was the state average. Our value, according to StatKey, is actually pretty close to that. It's not far off in the tail. It's closer to the middle. So it's about here. So that would be p hat, and that's my 0.176 from the sample. And then StatKey counted that about 0.299, so 29.9% of other samples would be smaller. Yeah. That's my p-value. Lots of p's floating around here. So in the middle is the proportion from the population. To the left or right of that falls whatever the sample proportion is. And the two of them together show me what the p-value is. Okay, and all those things have to work together. The sample size matters. The original population parameter matters. So that's my p-value. And again, next thing we do is we compare our p-value to our significance level, alpha. So 0.299 versus 0.05. That is way greater. Whenever you have a big p-value, you fail to reject the null. So that's the decision. If I fail to reject the null, I don't have evidence to support the alternative. That's the conclusion. You do not have sufficient evidence that, and then what comes next is whatever the alternative hypothesis happens to be. So I got to look back and see what that is. As usual, my alternative was this claim that I made there. And then I'm just going to restate that claim. And that's a conclusion. Maybe read it again. Okay. Portion. Hotel maids. With obesity. Less than. The population proportion of, and I'm going to state it as a percentage, 20.7%. So I don't have evidence that it's significantly less, there we go, than 20.7%. Given that every sample is a little bit different, this one is close enough to say, they don't seem that different to me. They're not far enough apart to be considered much lower. So according to this, on average, hotel maids have about the same proportion of obesity occurrence as adult women in New York. They're not much different on a subpopulation. All right, so that's again just review of how to do a hypothesis test with stat key. We were working on that last week, and we're going to work on it next week and the week after, and we're going to throw a few new things into it.